next preparation method is from alkanes. Alkanes when react with halogen in the presence of sunlight. Okay, so they give haloalkanes. Alkanes in the when react with halogen in the presence of sunlight. For example, CH4 plus Cl2 in the presence of light. It will give you CH3Cl minus HCl बाहर चला गया. Again, if you add Cl2 light minus HCl, so now no need of light. The reaction will go like this. Again chlorine minus HCl and again chlorine minus HCl CCl4. So this is methyl chloride. This is methylene chloride. This is trichloromethane, or you can say chloroform. And this is carbon tetrachloride. So all the 4 hydrogen of methane one by one substituted by halogen. So this type of reaction is basically called free radical substitution reaction. The reactivity of halogen follow the order. This and abstraction of proton follow the order. Okay, so suppose we have ethane and we are adding Cl2 in the presence of light, it will give you ethyl chloride. Okay, because both the 3 is there. Both the hydrogen are 1 degree. Now suppose we have a propane. Now this is 1 degree, this is 1 degree, this is 2 degree. When you add a chlorine, 2 products are formed. As we know that the abstraction of 2 degree proton is faster than 1 degree. So when you remove 2 degree, you get isopropyl chloride. When you remove 1 degree, you will get normal propyl. Out of these 2, this is the major product. And this is your minor. Okay. Major product formed is about 56%. And this is your 44%. So first we will do the mechanism, then we will see why this is 56 and this is how we can calculate this percentage. First we will do the mechanism of the reaction. So mechanism involves the free radical substitution. And the reaction takes place in the presence of light. So this reaction is called photochemical reaction. Photochemical reactions always have 3 steps. Step number 1, chain initiation step. In this step, what happened is here Cl, single bond Cl, when we follow light, undergo homolytic fission. What happened in homolytic fission? There are two electrons. एक इलेक्ट्रॉन ये ले गया, एक इलेक्ट्रॉन ये ले गया, और बॉन्ड जो है वो यहाँ से ब्रेक हो गया, तो we get a chlorine free radical. This is chain initial primary step. This is in which light is used. So this free radical then initiate the reaction. It combined with methane. Okay. Now this bond undergo homolytic fission. एक इलेक्ट्रॉन इसके साथ बॉन्ड बना लिया और एक नया फ्री रेडिकल जो है वो प्रोड्यूस हो गया. ये 11th में भी था. फर्स्ट स्टेप में लाइट की जरूरत है. दिस इज प्राइमरी प्रोसेस. बाकी किसी में भी लाइट की जरूरत नहीं होगी, उनको हम बोलेंगे सेकेंडरी प्रोसेस. ओके, नाउ नेक्स्ट इज स्टेप 2. chain propagation step. What happened in chain propagation step is this free radical which is produced here, that combined with the chlorine like this, and we get chloromethane plus chlorine free radical again is produced here. This chlorine free radical continue the chain. Propagation means to propagate. What this chlorine free radical will do, it will again combine with this only, abstract hydrogen from here. So I am writing it like this, and this chlorine free radical again producing a new free radical, and this new free radical again combined with chlorine to produce dichloromethane, and so on. All one by one, all the hydrogen get replaced by halogen. Now, third is chain termination. In chain termination step, what happens is that chain terminate. By chance, when two methyl free radicals they recombined to form ethane. By chance, the free radical produced, it back recombined with this. No new free radical is generated. By chance, these two free radicals they combined. So when there is no free radical, chain get terminated. So as you can see there, that ethane is also produced in this reaction. So the byproduct of this reaction may be produced, that is ethyl chloride. So question competition में पूछते हैं why ethyl chloride is formed? Because ethane is produced in termination step. That ethane undergo chlorination. इस पे भी तो क्लोरीन अटैक कर सकता है, देन इस पे करेगा तो क्या बन जाएगा, क्लोरोमीथेन. So So this is the mechanism of this reaction. Now you will see the abstraction of proton for chlorination. For chlorination, when we are using chlorine, the relative abstraction of 1 degree, 2 degree and 3 degree hydrogen are in the ratio of 1 degree hydrogen is to 2 degree hydrogen is to 3 degree hydrogen. So 1 degree को 1 ले लेते हैं and 3.8 and 5. This is experimental data which show that it's about 5 times easy to remove 3 degree proton as compared to 1 degree. Okay. For bromination, this ratio is different. For bromination, this ratio is different. That is 1:82 1600. This is for bromination. Now, based on this ratio, you can calculate in case of propane. Suppose we start with propane. And when you add a chlorine to it, we get two products. This plus this. 2 chloro and 1 chloro. What is the relative reactivity? How to calculate? This is found by replacing 2 degree, and there are 2 degree 2 hydrogen. So 2 degree hydrogen are 2, 1 degree hydrogen are 6. You can see here. जो 2 डिग्री है वो 2 ही है, 1 डिग्री वो 6 है. So 2 डिग्री रिप्लेस करके ये बना है तो कितने हाइड्रोजन है 2. तो 2 डिग्री की वैल्यू क्या है 3.8. तो ये कितना हो जाता है आपका 7.6. ये बना है 1 डिग्री रिप्लेस करके. तो इसकी रिलेटिव रिएक्टिविटी क्या होगी? रिलेटिव रिएक्टिविटी 6 into 1 that is 6. 6 into 1 क्यों किया? बिकॉज इसकी जो रिएक्टिविटी है वो 1 है. अब परसेंटेज, इसकी परसेंटेज निकलेगी 7.6. नीचे इसका और इसका सम 13.6 into 100. इसकी परसेंटेज निकलेगी 6 डिवाइड बाय 13.6 into 100. तो ये अप्रोक्सीमेटली 56% हो जाएगा. ये अप्रोक्सीमेटली 44% हो जाएगा. So in this way you can calculate the relative percentage of two isomers which are formed. So chlorination and bromination. Chlorination is very fast process. You can't add directly fluorine. Chlorination and bromination, these two reactions are easy. But fluorination is explosive. You can't add directly fluorine. Iodination के लिए iodination is reversible. Like for example, if we have a methane and we are adding a chlorine, it will give you methyl chloride plus HCl. If you have a methane and you are adding Br2, you will get methyl bromide. If you have a methane now and you are adding I to form, now this reaction is in equilibrium. So I will explain why it is in equilibrium. Yes. Now these three are reducing agent. and reducing tendency that increases. HI is strong reducing agent. It can reduce methyl iodide back to iodine. That's why this reaction is an equilibrium. So we can't get methyl iodide in a large amount. So what to do? The alternate is that we will use some oxidizing agent. During this reaction, we will use some oxidizing agent like HNO3, HIO3, oidic acid, nitric acid. So as soon as when we use this oxidizing agent, what happened? As soon as HI is produced, it reacts with this oxidizing agent to produce I2, 2NO, 2 water. Because this is your reducing agent, you know, and this is the oxidizing agent. So जैसे ये बनेगा, इसको कंज्यूम कर लेगा HNO3 और जैसे ही कंज्यूम हुआ, the equilibrium shift in the forward direction. Okay, तो HI will be consumed as soon as it formed. So equilibrium will shift in forward direction according to Lee-Chatelier principle. That's why we use some oxidizing agent. Okay, next. Fluorination is not possible. Direct fluorination is not possible. Fluorination is explosive. You can't add direct fluorine. What to do? We will use a method that's called halide exchange. We will take some chloride and change it to fluoride by halide exchange. So the reagents which are used for this is called fluorinating agents. You can use here Hg2F2. You can use here silver fluoride. You can use here SbF3 antimony tri or arsenic pentafluoride. So these are fluorinating agents. And this reaction is called Schwarz reaction. Okay. Suppose we have 2 mole of ethyl chloride, adding Hg2F2. What to get is 2 mole of ethyl fluoride plus Hg2Cl2. So this reaction is called Schwarz reaction. Okay. So this is the first binding reaction in this chapter. So this is the preparation of alkyl halide from the alkanes.